Okay, so you have a universal statement, which is the fact. When I say fact, it is true throughout the question. So if in the universal statement I write what if x is greater than 0, what is x? Now in the universal statement I have told x is greater than 0. That means x is going to remain greater than 0 throughout the question. There are no questions asked of this. This is a universal statement. And the universal statement will usually have two components. It will have components which gives you information, and it will have a component which actually asks you a question. By the way, are you guys able to understand my handwriting? It's pretty bad today.
No, it's clear.
Yeah. Okay. So universal statement will have some information in it, and it will have a question that is asked. And just like here, you have an information part and the question part. And the information part is going to stay true throughout the question. And then you will have statement 1. What is the meaning of having this statement 1? Statement 1 means that it will give you some statement about x. And using that statement, using the information in this statement, you have to tell the question, or you have to actually answer whether the statement is sufficient enough to answer this question. So if this is if x is equal to 3, now if is using this particular statement gives me what is x? Of course, yeah, it does, right? So that means this statement is sufficient. So there are two answers that a statement can give you. Either a statement could be sufficient to answer the problem, or a statement could be insufficient to answer the problem. Now this statement in here is particularly sufficient. Then you would be given statement 2. Now in statement 2, again, you have to follow the same process. Now the process is, again, if let's suppose x is greater than 5. Now does that give you the value of x? No, it does not. That means this statement is insufficient. So that is the structure of data sufficiency problems. So you have a universal fact, and you have the question, then you have the statement, then you have the statement, right? Now, any problem here, guys? Any question here before we move on to some complex things?
No. And one more thing, does it mean anything like if you get more of data sufficiency questions or less data sufficiency questions for the score?
For the test, are you talking about, like in your test?
Yes.
Again, if I take 1,000 GMATs, in that I will get 50-50. But within a test, it could tip either way. There is no such thing that you get more data sufficiency or you will get more problem solving. It's going to be completely random for you. But you will not get more than 60% data sufficiency or less than 40% data sufficiency.
So irrespective of how you are solving it, right or wrong, you'll still get 50-50 or something like that.
Yeah, it will tend to 50-50. Like in one test, you might get 50% data sufficiency, but in the next test, you might get 47%. In the next test, you might get 53%. The next test, you might get 45%. In the next test, you get 55%. So it depends from test to test.
It's not a reflective of any issues with the score.
Oh, no, it is not reflective of how you're doing in the test. GMAT does not consider data sufficiency to be difficult or more difficult or less difficult than problem solving. Okay.
Thank you.
Yeah, thank you. Okay. To the new guys, if you have any question, you can always let me know. You can use your audio to ask me questions. Okay. So let's move on. And if you guys are not comfortable using audio, you can always use the chat. There's a chat as well. Okay. All right. So what is the best approach to solving data sufficiency problems? Now, we have been given this particular structure that is, you have a universal statement, you have a statement one. Why is it doing that? Okay. You have a statement one, you have a statement two, right? So you have the structure. So what is the best approach? Now, before coming to the best strategy of solving different question types, let's set up a consistent process of how you actually solve the questions, because you have to first consider statement one, then you have to consider statement two, and then what if both are insufficient? Then you have to combine them. So there's so many different steps that you have to take. So what we're going to do is, first is we are going to have a consistent way of solving all data sufficiency problems. So a consistent approach. So this is a process, not a strategy, of how you actually solve data sufficiency problems. So let's say, sorry. So let's say you have a question. The question is, we're going to pick up the same question. If x is greater than 0, what is x, right? Okay, what is x? Sorry, let's cut that down. If x is greater than 0, what is x? First statement, x is equal to 3. Second statement, or let's say x greater than 3. Let me rephrase that. I'm going to do that. Hold on. Okay. Sorry about that. Okay. If x is an integer, what is x? First is x is greater than 3. Second is x is less than 5. Okay. Now in here, I've just put up an easy question, right? We will be just trying to come up with a consistent process. When you actually see a question, the first thing that you should do is read up the universal statement. And when you read up the universal statement, you are supposed to put everything down on the universal statement on your scratch paperwork. So the question says, if x is an integer, then you write down x is an integer, right? And then what is the value of x? And you should always say, oh, the question is asking me what is the value of x, right? So you do that. Then what you do is you first start with statement one. So then what you do is you start with statement one. And once you do statement one, it is going to give you two things. Either statement one is going to be sufficient, or statement one is going to be insufficient. So it'll have two possibilities, right? So if you look at this question, the question says, if x is an integer, what is the value of x? Statement one says x is greater than 3. We don't have a value of x. X could be 4, x could be 5, x could be 6. So that means this statement is insufficient. Okay. Now, what are the possibilities? If statement one turns out to be sufficient, then the answer is option A. If the statement one turns out to be insufficient, then there could be other possible answers. Now, if you are done with statement one, then what you do is you look at statement two, and then you find out whether statement two is sufficient or not. So first you look at statement one, then you look at statement two. And when you look at statement two, again, there are two possibilities. It can either turn out to be sufficient, or it can either turn out to be insufficient. Again, if statement two turns out to be sufficient, then the answer is B. If it turns out to be insufficient, then there are other possibilities. Now what do you do? If statement 1 turns out to be insufficient, statement 2 turns out to be insufficient, then you combine both the statements. So just like in this question, statement 2 is also insufficient. But now what do? You combine both the statements. When you combine both the statements, then you actually consider the facts from individual statements. You consider the fact from statement 1 and you consider the fact from statement 2 and you write it down. You have x greater than 3, you have x less than 5, and x is an integer. What is the possible value for x? Well, x has to be equal to 4 because there is only one integer between 3 and 5. Now, if combining it turns out to be sufficient, then the answer option is C. So it might seem very easy and very trivial for you right now, but when the questions get complex, understanding, drawing a line between statement 1 and statement 2, and then combining them, it becomes complex, and these basics will actually help you. So I'm going to repeat myself. First, you write down the universal statement on your scratch paper. You write down everything that is there. That is the universal fact. That is going to stay true throughout the question. Then you start with statement 1. You try to solve statement 1. It's going to give you two possibilities, whether it is sufficient or it is not sufficient. Then you will draw a line. Then you go on to statement 2 and try to find out whether it is sufficient or whether it is insufficient. And then you're going to combine both the statements to check whether it is sufficient or whether it is not sufficient. So what is the consistent process? Here is the consistent process. First, and again, this is in your official guide as well. So first, what you do is you look at statement 1. You look at statement 1. There are two possibilities that statement 1 can give you. It can either be sufficient or it can either be insufficient. If it is sufficient, then the answer option is A. If it is insufficient, then that means A cannot be the answer, right? That means the answer could either be B. That means so you have these 5 answer options: A, B, C, D, E. Well, A means that statement 1 is sufficient, statement 2 is insufficient. B means statement 1 is sufficient, not insufficient, and statement 2 is sufficient. C means combining it is sufficient. D means that statement 1 is also sufficient and statement 2 is also sufficient individually. And E means nothing is sufficient. So if statement 1 is sufficient, your answer is A, and statement 1 is insufficient, that means your answer is going to be B. Okay, so statement 1 is insufficient. That means your answer is going to be B, C, or E, right? Because that's what it is. If statement 1 is insufficient, it's either B, it's either C, or it's either E. Now, if statement 1 is now what you do is you go to statement 2 then. So if you go to statement 2, there are again two possibilities that can come out of it, right? Here it is. If statement 2 is sufficient, or statement 2 can be insufficient. So if statement 1 is sufficient and statement 2 is sufficient, then your answer is D. If statement 1 is sufficient and statement 2 is insufficient, then your answer is A. So if statement 1 is sufficient, there are two possibilities of answer, A or D. If statement 1 is insufficient, then there are three possibilities of answer, B, C, or E. And in here as well, you look at statement 2. Either statement 2 is sufficient or statement 2 is insufficient. If statement 1 is insufficient and statement 2 is sufficient, then your answer is B. If your statement 1 is insufficient and statement 2 is also insufficient, then what you do is you combine both the statements. And when you combine both the statements, there are two possibilities. Either it is going to turn out to be sufficient or it's going to turn out to be insufficient. If the combining turns out to be sufficient, that means the answer is C. And combining turns out to be insufficient, that means the answer is E. So that is the whole flow chart. And I'm going to summarize this right now. When you look at a GMAT data sufficiency problem, first you try to solve statement 1. You try to solve statement 1, you get two possibilities. Either it turns out to be sufficient or it turns out to be insufficient. If statement 1 turns out to be the sufficient, that means the possible answer options are A or D. And if statement 1 turns out to be sufficient, then you move on to statement 2. If statement 2 is sufficient, then the answer is D. If statement 2 is insufficient, then the answer is A. On the other hand here, if statement 2 is sufficient, the answer is B, and statement 2 is insufficient, then you combine both the statements. So when you combine both the statements, if combining turns out to be sufficient, then the answer is C, and when combining turns out to be insufficient, then the answer is E. Okay, so I'm going to take a moment here and ask you guys, is that clear to you?
Yeah.
So,
okay.
If A is the answer, then I can actually rule out between AD and BCE, something like that.
Yeah, so what you do is, once you draw statement 1, once you do statement 1 and it turns out to be sufficient, then what you do is you write AD. That means your answer is either A or D. Even if you're stretched for time, you can still take a guess and you can say, oh, my answer is 50-50. I have less time. Let me pick D and move on. And if statement 1 turns out to be insufficient, that means your answer is B, C, or E. Okay? Does that make sense? Lakshmi Narayan, does that make sense?
Yes, it does. Thank you.
Okay. So, like, for example, let's actually see a question. I'm going to show you a question here. Okay, let's actually see a question. Yeah. Okay, so let's actually see these questions, and what we're going to do is we are going to solve them together. I will solve the first two, and then I'll give you the next three for you to do. So again, here the job is not to show you a concept or anything, just to make you understand how data sufficiency works, how you actually solve data sufficiency problems. So it says if x and y are real numbers and 2x plus y is 11, what is the value of y? So you have this universal statement. So in my scratch paper, what I'm going to do is I am going to write down what is given to me in the universal statement. It says x and y are real numbers, and of course GMAT is always going to talk about real numbers, and it has given me that 2x plus y is actually equal to 11, and the question is asking me the value of y. Okay, first statement says x is equal to 2. Well, if x is equal to 2 and 2x plus y is equal to 11, I can easily get the value of y by substituting x in here. That means this is sufficient. The moment I get statement 1 sufficient, that means it's either answer option A or answer option D. BCE is not the answer. Then I move on to statement 2. I get x squared is equal to 4. If x squared is equal to 4, then x is either 2 or x is either negative 2. Again, I have two different values of x, and using this particular equation, I will get two different values of y. That means this is not sufficient. That means D is eliminated, hence A is my answer. And that is how you're going to do all the problems. You will first write down, again, these habits are very important. I mean, usually students find the first half of this class, or not the first quarter of this class a little boring because I'm not challenging you guys. But this is very, very important because it is very important to have a structure, to know how to solve these problems, and make this a habit of writing the universal statement and then doing statement one and then doing statement two. Because if you start doing things in your head, you're going to get them wrong. That is why it's very important to do that. So had statement 2 been sufficient, the answer would have been D, right? And here's one cool thing. Here's one cool thing that I will give you. Here's one cool thing that I will tell you, that if the answer is D in a data sufficiency problem, if the answer is D in a data sufficiency problem, then both the statements will give you the same answer. So if this gives you y is equal to something, this will also give you y is equal to something. Do you understand what I'm saying, Priyanka?
Yeah, I do.
Yeah. So let's look at this question number. Let's look at this question number 4. It says, what is the value of absolute x? The question is asking you the value of absolute x. Statement 1 says x squared is equal to 16. From here, you can say absolute of x is 4. So it is sufficient. It's either answer option A or answer option D. Now let's look at this one. It says x squared minus 8x plus 16 is equal to 0. If you solve this, again, you will get absolute of x to be equal to 4. So that means D is the answer. So when D is the answer, both the statements will give you the same answer, right? In GMAT, it will never be the case that if D is the answer, both the statements are giving you different answer. So whenever you're getting different answers, that means you're doing something wrong. Okay?
Yeah.
Lakshmi, is that fine? Gautam, did you understand what I did here?
Yep.
Okay.
Thank you.
Yeah. Okay. So let's start.
Got it.
Let's start with okay. So then I have another small thing to talk about before we move on to some questions, is that there are there's something important, that is the scratch paper setup. Whenever you solve a data sufficiency problem, make sure that there is a clear discrimination between what you're writing for the universal statement, what you're writing for the universal statement, what you're writing for statement 1, and what you're writing for statement 2. It's very important. I usually draw a line. So when I'm solving, whenever I'm solving, let's say a question, I always say, okay, this is the universal statement. So this says that x belongs to real numbers, and let me write. So x belongs to real numbers, and x is equal to 3. The question is asking me what is the value of y, and this is the universal statement. I will draw a line here, and then I'll say, okay, let's start statement 1, and then you do whatever you want to do in your statement 1 here, and then you draw a line here. Okay, let me do statement 2 now, and you do whatever you want to do with statement 2. And if I want to combine, I usually do it like this. I always put up the combination here. So, and I always put all the information that I have here, and then I solve the problem. Because if you don't stay organized, it's very easy to get confused. So you can have your own way of doing the scratch paperwork, but make sure that whatever you do in statement 1 stays in this zone. Whatever you do in statement 2 stays in this zone. And when you combine, there's a clear boundary between what you're doing. Does that make sense to everyone?
Yeah.
Okay.
Yes.
Okay. Okay, so let's start with some commandments for data sufficiency. There are some things that you should always do. and some strategies as well. So these are not strategies, these are tactics basically. So first commandment is that always first try to simplify the universal statement whenever you can. So always try to simplify this if it's possible for you. So the question says that, again, I'm going to solve this question for you. So it says if PQ is positive, then the question is asking, is this true or not? Now, before moving on to statements completely, what you should do is first try to simplify this, right? And that's a very good habit, and that will help you a lot. So what is this question saying? And see my scratch paper work as well, the way I'm solving it. It says PQ is positive. I'm writing PQ is positive. And the question is asking me, is P minus 1 equals to 1 over Q minus 1? So the question is asking me this. Now, what should I do is first I should simplify this and then move on to my statements. So basically the question is asking me, is P minus 1 into Q minus 1 is equal to 1? And then the question is asking me, is PQ minus Q plus 1 is equal to 1? And then the question is asking me, is PQ minus Q is equal to 0? So basically the question is asking me, is PQ equal to Q? Right? So that is what the question is asking me, right? And let me just make sure that I have done it right. So PQ minus Q, P into Q, this into this. Oh, I have actually solved it wrong. Give me a moment. So the question is asking you, is P minus 1 into Q minus 1 equal to 1? And then you have PQ minus Q, then you have minus P, then you have plus 1 is equal to 1. Sorry about that. Then the question is asking you, is PQ minus Q minus P equals to 0? So that is what the question is asking you, right? So you have simplified it. And then you move on to your statement. Now let's do statement 1. As you can see, I have messed this up, but I'm still going to make a boundary between statement 1 and the universal statement. The first statement says that P is equal to PQ minus Q. And that's exactly what the question is asking me, right? See, you can see that is exactly the same thing. That means this is sufficient, right? And this will actually help you a lot when you do that. You have to always simplify the universal statement. I will not move on to statement 2 yet, but I wanted to make this point that rephrase the question, and that would be very, very important. That's commandment number 1. Moving on to commandment number 2. Sometimes you can work backwards as well. Sometimes this is easy, but the statements are complex. Then you don't need to rephrase the statement. So if you look at this question, this says, what is the value of x minus y? That just means the question is asking you the value of x minus y. There's no solving it. There's no making it easy here. And sometimes it would be quoted in complex things that you will not be able to figure it out, but you'll have to figure it out. From statement 1, you can clearly see that x is equal to y plus 2. That means x minus y is 2, right? So sometimes you'll have to simplify the statement and then go to the universal question, right? So that is something that you can do. So either you rephrase the question or you rephrase the particular statement, right? That's commandment number 2. Let's talk about before that. Is there any question on this? These are easy things. Is there any question on this, guys?
Just a quick question. Because when I see these variables, even with data sufficiency, I tend to start plugging. I start to plug in. So I'm wondering, is that not time efficient?
No, we are going to do plugging in data sufficiency as well, and it is actually extremely important. But with the data sufficiency, what it is that you have to be really careful when you're plugging in. You have to be really careful, and there are some important clues the question will give you that are you supposed to plug into this question or not. It is different than problem solving. In problem solving, if you see the answer options, most of the time as variables, most of the times you plug in. But in here, in data sufficiency, it's different. We will do that in the later part of this class today.
Okay.
Okay. All right. Okay. Now let me also talk about the negation test. Now that's again another commandment, is that what you should do is that you should, again, as I've said in the previous class as well, that disproving is actually easier than proving. So if the question asks you something, if the question says, and if you see this particular question, y is not equal to 0. So that means it says y is not equal to 0. The question is asking you, is yz greater than 0? That's what the question is asking you. So statement 1 says y is greater than 0, right? So this does not say anything about z, right? So that means this is insufficient. It's either answer option B, C, or E. Now let's look at statement 2. Statement 2 says 1 over y is less than z, right? And 1 over y is less than z, and the question is asking you, is y into z greater than 0? Now, what you can do here is that you can use numbers to actually try to get the answer. So what you can do is, all you have to do is you have to use such numbers that you suffice the statement and you suffice whatever you have in a universal statement, and then you try to see whether this gives you different answers or not. So 1 over y is less than z, right? So you can come up with many numbers which actually tell you that. Now here you can solve it algebraically as well, but I'm trying to solve it using numbers. So 1 over y is less than z. So you can have some numbers. Let's suppose y is equal to 3 and z is equal to, let's say z is equal to 1. So 1 over 3 is less than 1, right? Now is yz greater than 0? So is yz greater than 0? That means is 3 into 1 greater than 0? Yes, it is greater than 0. So once you get a yes, what you need to do is, to make this statement insufficient, you need to have a no. So this is a particular type of data sufficiency problem. It is a yes-no data sufficiency problem. Even in data sufficiency problems, you have two types of questions. Questions which ask you specific answers. That is, what is the value of x? And then there are other types of questions which asks you yes or a no. Is x greater than 0? Is x less than 0? So they have only two answers. They have only answer yes, and they have only an answer no. So to disprove here, what you need to do is to make this statement insufficient. Once you get a yes, you should look for a no. So for me to look for a no, I need to make y into z less than 0. So what I can do is I can make y as -3 and z as 1. If that is the case, still the statement is sufficient, because I will not use the word sufficient, but still the statement is satisfied that 1 over y is actually less than z. And is y into z less than 0? Greater than 0? No. -3 into 1 is actually not greater than 0. So I have a yes, I have a no. That means the statement is insufficient. So I'll just summarize what I did here, that whenever the question asks you, is something possible, to make that insufficient, to make your statement insufficient, what you have to do is you have to first use numbers that make it possible, and then you have to use some numbers that make the statement not possible. So you have to get a yes and you have to get a no, and the statement is insufficient. Do you have any questions on this? This is going to get a whole lot complex later on, but this is an easy question. Do you have any questions on this? Gautam, do you have any questions on this?
No. I think we can move on.
Okay, Priyanka?
No, I'm good.
Okay. Lakshmi Narayan? Okay. Okay, so the next commandment is assume nothing from your side.
Thanks.
Do not assume anything from your end. So if you look at this question, the question says, is x an integer? So that means x is so the question is basically asking, is x an integer? That's what the question is asking you, right? First statement says x squared is an integer. Okay, I'm gonna ask you this question. Tell me, if x squared is an integer, do you really think x is going to be an integer? Just give me your answer, yes or no.
No.
No, right? Because what if x is equal to square root 2? If x is square root 2, that means x squared is an integer, but x is not an integer, right? But on the other hand, if you have x to be equal to 2, then x squared is an integer and x is an integer. So that means you have a no and you have a yes, right? So that means the statement is insufficient. Even this is insufficient. But what I want to say here is that do not assume anything. That means if it says x is an integer and it says x squared is an integer, try to use your imagination to come up with numbers, come up with information that will make this statement insufficient. And as I said earlier as well, always try to disprove the statement first. Always have a skeptical mind. Try to disprove the statement first and do not assume anything. So what does that mean? That means you should try some unorthodox numbers into these statements, like x is 0, like x is -1, like x is numbers between 0 and 1, numbers between 0 and -1, and of course complex fractions. So you should always try, you should not assume anything firstly, and you should always try very unique numbers to actually disprove the statement. That's commandment number 3. Before we move on to plugging in, any question, guys?
Are there any set of numbers that are like standard that we can use?
Yeah, so there is no particular standard in here, but because it's going to be very specific to the question. But there are some numbers which can make or break the question, and which actually GMAT loves a lot. And those are very simple numbers, like 0, 1, numbers between 0 and 1, numbers between 0 and -1. So those are the numbers, and I call it. I usually give students this advice that it's always about being zoned. Always try 0, always try 1, always try negative numbers, always try extreme numbers, and always try decimals. So try these different set of numbers all the time. 0, 1, negative, extreme. When I say extreme, sometimes numbers greater than 10 will work. Sometimes numbers greater than -10 will work. Less than -10 will work. So if you try all these different type of numbers, then it will work out for you. Is that okay?
Yes.
Okay. Gautam, are you fine?
Yes.
Okay. Okay, now let's actually get to the gist of it. Let's actually start with our first strategy, which is plugging in data sufficiency. Again, as I have talked about in the previous few minutes, is that always attempt to disprove the statement rather than proving the statement. And here's one mantra that I have. If you're trying to disprove something, you should always use numbers. And if you're trying to prove something, you should always use algebra or math. So disprove using numbers and prove using algebra. That should be the mantra, because you can never prove using numbers. Because if I say, let's say if x is an integer, what is the value of x? And if I say x is greater than 3, right? Then is the value of x equal to 4? Is the value of x equal to 5? you'll be moving on and you'll be plugging in numbers and plugging in numbers. You can't prove it. So you should always disprove using numbers. Numbers help you disprove something, and algebra, math actually helps you prove something. And this is going to be your mantra in GMAT. So if your first attempt at a particular statement should be to disprove it. And if you're not able to disprove using numbers, what if the statement is actually sufficient? Then you should take a step back and say, oh, what am I getting? Or what are these numbers showing me? And from there, you use algebra. Right? Let me solve a question for you. But before that, is there any question here? Do you have any question? Gautam, Lakshmi, Priyanka?
I'm good. I'm good.
I'm good, yeah.
Okay. Okay. Let me get to a question. Should I do this? Okay, let's actually see this question. So this question says that if P and Q are, so now we're going to be doing questions completely. So the question says if P and Q are positive integers. So P and Q are positive integers. So they are greater than 0 as well. So the question says, and 1 plus P plus Q plus PQ is equal to 21. So the question asks me the value of P. Again, look at that. Scratch paper is very, very important. Write everything down on your scratch paper so that you're not looking at the screen all the time. And again, have your own way of writing things down. This is the way I denote an integer. You can have your own way. This is the way I denote that they're positive and all that, right? Okay, so the question is asking me the value of P, right? First statement says Q is greater than 3. So then this particular statement, it says Q is greater than 3. And the question is actually asking me the value of P. So what should I do? I should start with numbers, right? I can do that. But again, you should not think about the question and start with numbers right away. You should understand the context of the question. What is the question trying to ask me? Which is why this knowledge is pretty tacit. I can't actually put it down here, which is why I'm solving this question with you. You should actually have a look at the question. That's what I'm trying to say. So this question says, again, Q is greater than 3, and you have this particular thing. 1 plus P plus Q plus PQ is equal to 21. Now, what is the first number that you should try? Give me your answer to this. What is the first number that I should try?
4.
Maybe a 0.
You can't. So, okay. So I'm going to start with numbers for Q. I'm going to plug in a number for Q. So what is the number that you're going to try for Q? Because it says Q greater than 3.
4.
4, right? So what you should do is you should always start with the most obvious number. Q greater than 3, start with 4. Start with the smallest possible numbers. And when you are plugging in numbers, be very aware of what you're doing. Be very aware of how the constraints in the question are playing together and how they're working out. So, and this is an approach that I always follow. Whenever I plug in and I know that I'll have to plug in multiple times, I always work in columns. So Q is 4, right? And then if Q is 4, then what I will do is I will have to plug in Q as 4 in here, right? So what will I get if Q is 4? So then I have 1 plus P plus 4 plus 4 into P is 21. Then if I solve this, that means 5 times P is equal to 21 minus 5, right? Now, I actually have a hunch. What hunch I have is, I think I need to simplify this, right? So I'm following one of my commandments because there is something that can be done out here. So let's actually do that. So 1 plus P plus Q plus PQ, okay? So what does this become? 1 plus P, I'm going to take Q out here. So that is 1 plus P. So you have 1 plus P out both sides. I have 1 plus P and I have 1 plus Q is equal to 21. Now that makes it a lot easier. Rather than plugging in here, what I can do is I can plug in here. And from here, you can actually figure out something. 1 plus P into 1 plus Q is equal to 21. And what is 21? 21 is 7 into 3, basically that, right? So if Q is 4, then what do I have for, and again, they are all integers, right? So very important there. So if Q is 4, what is 1 plus Q? Sorry. 1 plus Q is equal to 5. If 1 plus Q is equal to 5, that means it is not going to work out, because what is going to be 1 plus P? 1 plus P is going to be equal to 21 divided by 1 plus Q, 5, which is not an integer. That means P will not be an integer. So this number is invalid. Let's try the next number. We try the next number, Q is 5. Q is 5. What is 1 plus Q? It is 6. What is this? This is 21 over 6. Not working out. You should start seeing a pattern here. What is the next number? The next number is 6. If Q is 6, what is 1 plus Q? 1 plus Q is 7. And what is 1 plus P? 1 plus P is 21 over 3. That means what is P? This is 7. That means P is also equal to 6. And these are the numbers that work out. If you keep going forward, none of the numbers will work out. And you should stop right there. You should start seeing a pattern here. That means this is the number set which actually works. So that means Q is 6 and P is 6. And this statement is sufficient. Did you guys understand what I did here? Any questions?
Yes, but there's a small miscalculations.
Okay.
1 plus P would be 21 by, say, 7, not 21 by 3.
Oh, 21 by 7. Okay, fine.
Yeah.
That is going to be.
Though we understood, so it's fine.
Yeah, but still that will give you the same answer. So again, another important thing is, look at this. Q is given to be 6 here, and Q is also given to be 6 here. Again, the same thing is that if both the statements give you the same, both the statements have to give you the same answer. This is also going to be sufficient because this automatically gives you Q equal to 6. So it gives you the same answer. Priyanka, Lakshmi, do you have any question here?
No, it's all good. Thanks.
No, it's thank you.
So what I'm trying to say here is that these data sufficiency problems, there is no one way of approaching them. And you should always look at the question, look at the context, what is happening, and always be ready to take a step back and kind of change your approach. I was going for plugging in here, but then I realized I need to simplify this particular statement here, 1 plus P plus Q plus PQ. And then that actually gave me very interesting 1 plus P into 1 plus Q, which actually helped me plug in. So it's not just plugging in and algebra, they actually go together. And it's kind of a balance that you have to bring when you actually practice questions. So let's try and solve a question together. Let me give you a question. Give me a moment. Okay, so why don't you solve this question? And I will give you 2 minutes for this, okay? Guys, are you able to see the question?
Yes.
Okay, great. Okay, guys, did you get the answer?
Yes.
Okay, so what is your answer? A, B, C, D, E?
It's. I just forgot. Hold on. It's D.
Okay. Lakshmi, did you get the answer?
Yeah, I think it's C.
Okay. Priyanka, did you get an answer?
Yeah, I think it's D.
Okay. B, you said B as ball.
Yeah.
Okay. Okay, so let's look at this. So first of all, universal statement says A is, it says A is not equal to 0. The question says, is A cube greater than A square? Now in here, I feel I should simplify this, right? And by simplifying, one thing that I should understand is I can't just cut the A's, right? I can't do that. So here's what do I have to do? I have to say, is A cube minus A square greater than 0? So the question says, is A cube, so you take A square out of it, that is A minus 1 is greater than 0. Now, A square is always going to be greater than 0 because that's what A square is. It's square of any number is positive. That means the question is basically asking me, is A minus 1 greater than 0? So the question is asking me, is A greater than 1? So all I have to tell the question is A greater than 1. So that's using one of the commandments, simplifying this before moving on to the statements. Let's move on to statement 1. Statement 1 says 1 over A is greater than A. Let's try to think what kind of numbers work here. Will numbers greater than, and again, the question is asking me, is A greater than 1? Let's try to see whether A greater than numbers work here. Will 2 work here? No. 1 over 2 will not be greater than 2. Will 3 work? No. Will 4 work? No. That means on this number line, numbers greater than 1 are not going to work. That means numbers less than 1 are going to work, right? So if I think about trying to plug in a number to actually negate this, always try to negate initially what the statement is asking you. So is A greater than 1? I cannot plug in a number which says A is greater than 1, which means A is sufficient. Hence, it's either answer option A or it's either answer option D. Okay, I'm going to stop here and ask you questions. Did you guys understand what I did here? Any question on this?
No, thanks.
Yeah. So the
I'm
take.
good.
So the,
I'm good. I'm good.
okay.
Sorry.
So the takeaway from here is that if the question asks you something complex, simplify it. And then when you try to plug in numbers, always try to think the opposite of what this is trying to ask you. Not always, but most of the times. Think what is the opposite of this. And if you can't think what is the opposite of this, that means it should be the other way around. And if you think about it, the only numbers that work here are negative numbers and some fractions. Now let's move on to statement 2. Statement 2 says a to the power 5 is greater than a to the power 3. Right, so that's what it says. A to the power 5 is greater than a to the power 3. Now, since I know that a is not equal to 0, what I can do is I can divide this at least by a square, and I can remove the complex powers out of it, because a square is going to be a positive number, and dividing by positive numbers on both sides does not change the signs. So basically what the question is saying is that a cube is actually greater than a. Right, so that's what the question is telling me. A cube is greater than a. Yes. Okay, now I have two routes. One route is I can plug in here, or I can use some algebra here. Let me start with plugging in. Okay, what is the number that actually works here? First is number 2 will work. Numbers greater than 1, because 2 cube is my, so this is what I call fact. Is my fact satisfied? A is not equal to 0, a cube is greater than a. Let's check whether my condition, what does my condition tell me? Is a cube greater than a square? Is 2 cube greater than 2 square? That's a yes. Now what do I have to do is I have to find a no. I have to find something that satisfies the fact and gives me a no. So what number will be that? What number where a cube is greater than a, but a cube is not greater than a square? That is a negative fraction. So if I say a is negative 0.5, so in a negative 0.5, negative 0.5 cube is greater than negative 0.5. But negative 0.5 cube is not greater than negative 0.5 square. because this turns out to be positive then. So that means that is a no. This is not sufficient, and A is my answer. Oops. Okay, guys. Did you guys understand what happened here?
I missed the negative 0 to -1. I missed those number lines.
Yeah, and
So
that was key to the question, actually. That was the only
yeah.
So remember, Z-O-N-E-D. Try 0, try 1, try negative numbers, try extremes, try the decimals. And the numbers that I always try in these kind of questions are 2, -2, 0.5, -0.5. These are the 4 set of numbers that I have to try. Lakshmi Narayan, did you understand? Priyanka?
Yes, I did. Yeah. Thank you.
Yes, thank you.
Okay. Okay, let's actually see another question. Okay, so here it is. Some of the numbers that will help you to disprove is 0, 1, negative number, extremes, and decimals. Okay, why don't you guys try this question? Are you guys done?
Yep.
Okay, so what is the answer that you guys got? Just give me the number.
E.
E, okay. Lakshmi Narayan and Priyanka, what answer did you get?
Still confirming. Hold on.
Okay.
I got E as well.
Okay.
Yeah.
Okay, so let's see this question. So the question says, which is greater, is this or this? So basically the question is asking me, is x over y greater than x over y plus 1, right? That's what the question is asking me. Statement 1. Again, I have to write it down. Y is not equal to 0. Y is not equal to -1. Statement 1 says x is greater than 0. If x is greater than 0, what I can do is I can cut x from both sides because it's a positive number. So basically the question is asking me, is 1 over y greater than 1 over y plus 1? So let's start with some numbers. What if y is 2? Then my fact is satisfied. When I say facts, I mean, is x greater than 0? Is y is not meeting all these numbers? The fact is satisfied. What about the condition? Is 1 over 2 greater than 1 over 3? Yes. Let's try a negative number. I'm going to try negative 0.5. If I try negative 0.5, the fact is satisfied. But here is 1 over negative 0.5, which is a negative number, greater than 1 over negative 0.5 plus 1, which is a positive number. Can a negative number be greater than positive? No. So this is insufficient. It's either answer option B, C, or E. Move on to statement 2. X is greater than y. Now, if x is greater than y, and you could see from the numbers here, x is, I think, irrelevant to the question. You can have any value for x and still get the same answer, but we're going to try either way. So let's try for x and let's try for y. I'm going to keep 2 and negative 0.5. Why? Because if this statement is also insufficient, I don't even need to combine because I'm using the same set of numbers for y. So that means that I won't even need to combine when I get this statement to be insufficient. So let's talk about conditions. So if I keep if y is equal to 2, let me keep x as 3. And if x is 3, and you can see x will eventually cancel out, right? And if I keep x as 3, and you can see x will eventually cancel out, and x is greater than y, that means it's a yes and a no. This is also insufficient. And I don't even need to combine because I'm using the same set of values for y. So that means the answer is E. You guys understood what I did here?
Yes.
Yep. Yes, absolutely.
So here, and these are the small decisions that you will take in your GMAT, using the same set of numbers. And you have to be very careful about, because if you don't start with a clean slate from statement 2. Learn what you learned from here about the question and apply it here, right? So that you utilize your time to a maximum.
Hey, quick question.
Yeah.
How did you manipulate that equation from x over y to 1 over y? I didn't really.
Are you talking about this, what I did here?
Yeah.
So if x was positive, I could cut the x on both sides. So x over y plus 1, is that greater than x over y? If x is positive, I can remove x from both sides because I can divide both the equations by x and x will get eliminated.
Okay.
Yeah. Okay. And again, one more thing is that when you guys practice, always, whenever you solve a question, hold yourself there and try to understand what was the takeaway from this question. And if you keep on accumulating your takeaways, it will only take you about 100 questions in data sufficiency to figure out everything that data sufficiency has to offer you. So learn takeaways from every question. That's what I want to say. Okay. Algebra to prove and numbers to disprove. Okay. So again, I call it tunnel vision, as I've told you before, that algebra to prove and numbers to disprove. You will start your questions by algebra or by numbers, and I usually start with numbers, and that will give you some context to the question. If you're not able to solve it, and if you are using algebra here, take some learning from here, understand the pattern, what is happening in the question, and then when you start using algebra, use the patterns that you generated from the numbers into your algebra, and understand that, oh, this is what is happening. I'm only getting positive numbers. Why is that? This is the case. Then use algebra on it. So let's solve this question, and I'll give you 2 minutes again. Why don't you guys solve this one? Okay, guys, did you get an answer?
Yeah.
Yes.
So what is the answer?
A.
A, okay. What did you get, Gautam, Lakshmi Narayan?
Yeah, I too got A.
Okay. Okay, so it says if x into y is less than 15, is x less than 1, right? So x into y is less than 15. The question is asking me, is x less than 1? I hope I'm able to change some habits of scratch paper for you. But first is y is greater than 15. So, all right. X into y is less than 15. Is x less than 1? Y is greater than 15. Now let's try to negate this. Can I think about a number which is greater than 1, but makes x into y less than 15 with y being greater than 15? I cannot, right? 2, 3, 4 will work, but I'm thinking about fractions, so nothing is going to work. And why is that? This is where you have to use algebra, right? Because numbers to disprove, algebra to prove. Why is that? Y is greater than 15 if the only way to have x into y less than 15 is if x is less than 1. I don't need to write it down, but I think that's obvious. So this is sufficient. It's either answer option A or answer option D. Let's move on to statement 2. It says x is less than 15. Now, x is less than 15 and x into y is less than 15. Well, in here, there are two possibilities. X could be 3 and Y could be 4. On the other hand, X could be half and Y could be 4 as well, right? Because in both cases, X is less than 15 and X into Y is less than 15. So this is insufficient and answer is A. Okay, guys, is this fine, right?
Yes.
Okay.
Okay.
All right, let me give you a hard one. Okay, try this. Oh, am I writing this? Did you get the answer, guys? I think this was an easy one.
Is it A?
Okay. Priyanka?
Yeah, A.
Okay. All right, let's see this. So this says A minus B is greater than 10. So the question is asking me, is A minus B greater than A plus B? And I can simplify this. I can cut A on both sides. Can I do that? No, I cannot do that. Is A minus B greater than A plus B? Okay, I think I can do that. So so I can cut A on both sides. So the question is asking me, is minus B greater than B? So the question is asking me, is 0 greater than 2B? So basically the question is asking me, is B negative? Okay, let's look at.
I just found out over here. So in this, you have simplified the equation and you've cancelled A. But if A is positive, then only you can cancel it, right? As in, that's the seal.
No, what I'm doing is, so is A minus B greater than A plus B? I'm just subtracting A on both sides of the equation. So I'm not multiplying or dividing. I'm just adding or subtracting. So like -3 is greater than -2. Let's add 2 to both sides. So actually you are correct. I can't do that. That's what I thought. I can't do that. Yeah.
But for equation 1, you can do that. For equation 2, you can't.
Yeah. A has to be positive in that. But I thought I can't do that, but then I did that. Okay. So let's just write that. A minus B is greater than 10. So the question is asking me, is A minus B is greater than A plus B? And again, I guess, guys, this is an important exercise for you guys as well, that if you think that you can't do that, always take an example, like just the way I did. Like, can I add the same number on the both sides? Just take an example. It's -3 is greater than, oh, actually I can do that. Hold on, I took a wrong example. -3 is greater than -4. If I add 4 on both sides, yeah, adding and subtracting I can do. I cannot multiply or divide. So in this case, 1 is going to be greater than 0. So if I add the same number on both sides or subtract the same number on both sides, I can do that. But if I multiply and divide, I cannot do that. Like if I say -3 is greater than -2, if I multiply -1 on both sides, then it will not.
That would reverse. That would reverse, but
it's only multiplication and division which reverses
division.
the sign, but addition and subtraction will not reverse the signs. Think about it. Like, give me let's take an example. -3 is less than -2. Can you add any number which will reverse the signs?
No.
Right? So -2 and -2. If you do -2 on both sides, you still get the same thing.
Yeah.
So I can remove them. The only problem is when I can't remove them is when they are multiplied or divided. That's the only thing.
Yeah, that's okay. Cool.
So basically the question is asking me, is B negative? First statement says A is 7. What I should do is I should substitute here. If A is 7, that means 7 minus B is greater than 10. That means minus B is greater than 3. That means B is less than -3. That shows that B is negative, so this is sufficient. Second statement, it's either answer option A or D. Gives me B is -18. This also tells me B is negative. This is sufficient. A is gone, D is my answer. Did you guys understand? Nakshminarayan, Priyanka?
Yeah.
Yeah. So,
Yeah.
Yeah, I wonder, I had written spooky on it. It was a spooky question. So yeah, so be careful, simplify the whatever is given to you at the top and then just do it. Okay. That was taken care of. Now let's move on to the other one. Now we will be doing something really cool. Where is it? Here it is. Okay. Now here are some things, some strategies that I actually want to share with you. And these are the strategies that I have acquired through my practice. And it's been, this is the 8th year I'm actually teaching GMAT. So going through all that, there are some important things. Like when I started doing GMAT like 8 years ago, I used to, in practice tests, sometimes I would score a 50 and I would go mad why I did that. And then when I looked at the questions that I got wrong, those were such subtle mistakes, and those actually gave these strategies to me. And these are very important strategies. First strategy is, oh, where am I starting this? Okay, you guys are able to see the PPT, right?
Yes.
Yes.
Okay, so the first strategy is go all the way. When I say go all the way, don't leave anything to the imagination. Always, like, have the answer in front of you. Like sometimes we think, oh, you have two equations and you have two variables. You should be able to get the answer. Don't ever fall for that, because the hardest question will trick you in that way. So let's look at this question. So this question says that is y a positive number? So the question is asking you, is y greater than 0? First statement says negative 5y. Hold on. So negative 5y is minus 3 is greater than negative 2y, right? So so don't just think about this and try to get the answer. Just solve it all the way and do it step by step. So negative 5y plus 2y is greater than 3. Then you have negative 3y is actually greater than 3. And now the signs are going to flip. So y is less than 3 over negative 3. So y is less than negative 1. So that means this over here is insufficient. Sorry, sufficient. So this is sufficient. So it's either A or D. Then move on to the second statement. Y square is positive. Now, if y square is positive, y could be, again, a very, so whenever you have something like this can actually be broken down to y greater than 0 and so y can be positive and y can be negative from here. But what I wanted to say is that whenever you have something like x squared greater than a, this can be broken down to x greater than a and less than negative a, sorry, square root. So if I say, so this is just a conceptual thing that I want to tell you, that if I say x squared is greater than 4, that means x is either greater than 2 or less than negative 2. So you can actually break this complex thing into this. Did you guys understand this?
Yep.
Yeah, but what I want to say is go all the way. When I say go all the way, do all the steps and get to the gist of it, right? This question was not that tricky, but what I wanted to say is that sometimes there would be a trick involved in here, and you have to go all the way. So again, a conceptual thing that came out of it, if you see this, you can actually break it down to something like this. Anyhow, why don't you guys do this question? And here it will be very important for you to go all the way. It'll take 2 minutes.
So I have a small doubt over here. So let's say says that if ST is negative and if I'm getting an answer as a 0, so should I consider that to be a negative?
No,
A
zero is a non-negative integer.
non-negative integer.
Yeah.
Okay.
Yeah.
Fine. Thank you.
Okay, guys, did you get the answer?
Yep.
Okay, so what?
Is it Bombay?
Okay.
I know it's Bombay.
Lakshmi and Priyanka?
I got C.
Okay.
I know.
Priyanka, what did you get?
C.
Okay. Okay, so let's look at it. So it's the product ST negative. So the question is asking me, is ST less than 0? First statement says S square minus S is less than 0. Simplify it. S into S minus 1 is less than 0. Understand what is happening here. So here, we don't know anything about T. So even if you figure out that S is positive or S is negative, it will not give you anything. So like in this here, it says the product of S and S minus 1 is negative. So like from here, what can I get? Again, S cannot be 0 here, because this, if S is 0, then this whole thing is 0, which is not possible. So that is there. Another thing is, if the product of two numbers is negative, there are two possibilities that come out of it. Either this is positive or this is negative, or this is negative or this is positive. Right? So if product of two numbers is negative, either of them has to be negative. Both of them cannot be positive, both of them cannot be negative. So that means the two cases, and again, I'm using algebra here, I'm not plugging in yet. So they both go in hand. So there are two possibilities. Either S is negative or S minus 1 is positive, or S is positive and S minus 1 is negative. So either S is negative or S is greater than 1 at the same time, which is not possible, or either S is positive and S is less than 1 at the same time. This is not possible. The only thing that is possible is this. So that means for this inequality to work, S has to be between 0 and 1. That is what statement 1 tells me. But I don't know anything about T. So this is insufficient. So the either answer option B, C, or E. Let's look at statement 2. It says S minus 4 is equal to T minus 3. It says S minus T is equal to 1. Or basically S is equal to T plus 1. Or T is equal to S minus 1. So if this statement itself is insufficient, why? Because it just says that S and T are consecutive integers. That is the only thing it tells me. So let me think about that. So so again, go all the way. I'm trying to go all the way here. Let's say S is, again, S could be 0 here, right? So if S is 0, then what is T? T is negative 1. What is ST? 0. What do I get here? I get a no. Is ST less than 0? No. Let's try some other number. Let's try S to be negative 1. Then what is T? T is negative 2. What is ST? ST is 2. Is ST less than 0? No. I have to get a yes. Let me think about how I'm going to get a yes. Okay, let's try. Can I get a yes? Let me think about that.
I guess no. You can't try. You can't have a yes over here.
You will only get a no all
Yes.
time, right? Yeah.
Yeah.
Which is why this question was go all the way. So I'm trying to go all the way. So basically, I'm getting a no. Let me put my head around it. S and T are consecutive integers. If S and T are consecutive integers, can their product be ever negative? And for their product to be negative, one has to be positive and the other have to be negative. And it is not possible, because if you look at the number line, this is 0, this is 1, this is negative 1. The only consecutive integers will give you 0. If you go beyond that, it will start giving you positive numbers. Negative 2 into negative 1 gives you positive. Negative 2 into negative 3 gives you positive. 1 into 2 gives you positive. 2 into 3 gives you positive. So that means this actually is sufficient, and B is my answer. Did you guys understand what happened here? Lakshmi Narayan, Priyanka?
Yes.
Priyanka, did you get it?
Yeah.
Sure about that?
I still have to like see what I did to you know, see
Okay.
where I went wrong. But
Yeah. So my takeaway from this question was you have to go all the way. See, when I was solving this, I was saying, oh, this is just two equations and S and T could be anything. So this is insufficient. I was going to go combining, but then say, oh, hold on. Let me try to find a yes and a no. And I was always finding a no. And then that struck me and then said, oh, it is not possible for S and T to be negative. S and T, the product to be negative because they are consecutive integers, right? So go all the way whenever you can. All right. Another strategy which is important is convert your English to math whenever you see word problems, especially word problems. So basically, if you look at this question, the question is asking, is average of X and Y less than 40? Don't just let it sit like that. Say, okay, is X plus Y over 2 less than 40? Convert this English to math. And that will make, and basically if you look at all the GMAT questions, there are like I would say 40 to 50 type of questions in data sufficiency, and even in problem solving they have a skeleton on it. And then what question makers do is they just add context to the skeleton. So you have all those. So whenever I used to make questions for GMAT, I used to say, okay, let me ask this question, is X greater than Y? And in how many ways can I ask questions, is X greater than Y? I can give it a statistics context. I can give it a counting context. I can give it a geometry context. I can give it so many contexts. So basically what you're supposed to do is understand the English of it and convert the question into math. So this, if you look at the first statement, how would you do that? The average of 3x and 3y is 117. So 3x plus 3y over 2 is 117. Okay, so start developing that habit. This is actually way too easy as a statement, but there are going to be complex statements in future where you read the statement and you have to convert the math of it, right? So that's strategy number 2. And strategy number three is that usually GMAT will not ask you common sense questions, something that you're supposed to infer yourself. But one thing that it will give you is that there are going to be some invisible constraints in the question. Like this question, is the number of boys greater than 17? What else constraint that you have? What is the other constraint that you have in this? Is if I say is B greater than 17, is there any other constraint in here? Okay, I'm asking you a question. Is there a hidden constraint here? First of all, number of boys have to be an integer.
Yeah.
Number of boys has to be positive, right? You got that, guys? Did you understand?
Yep. Absolutely.
Yeah. So these are the constraints. And actually, if you try to solve this question, which I won't do because it's very easy, it's this whole question actually sits on this constraint. If this were an algebraic question, if I say instead of number of boys, if I ask you is X greater than 17, then the answer would be something else. So there are going to be invisible constraints in the question. And whenever you see number of boys or number of girls or number of students, this constraint is always going to be there. And this is actually an official GMAT question. So they use that, and they will not give you the context. They will not tell you the number of boys is an integer, something that you'll have to infer yourself. So that is strategy number 3. Okay. All right. So strategy number 4, there is a difference between inequality and equality. And it's something that we just did 5 minutes ago, that in an equality, you can multiply and divide on both sides as you like. But in an inequality, you can't do that. Like in an inequality, you cannot just multiply and divide on both sides. Because if you multiply and divide by a negative number, the sign will flip. So if I say that A is greater than B, then negative A is actually less than negative B. But that does not happen in an equality. right? In equality, if A is equal to B, then negative A is actually equal to negative B. So understand the differences between equality and inequality, what you can do, what you cannot do. And if something is something that you can do, always try to do it. Like if I say, is A cube greater than A square? Divide both sides by A square, given that A is not equal to 0. You can do that because you can divide by a positive number and the sign will not flip. It's just the negative numbers that you have to be concerned about. So if you know that something is positive, you can divide by that, right? Unless you don't, if you don't know the sign of anything, then don't do that operation. Am I making sense here, guys?
Yeah.
Yep.
Okay. So why don't you do this question? It's a very tricky question. Why don't you do that? Take 2 minutes. Okay, did you guys solve it?
Yeah.
Okay, what's the answer?
I got B.
Okay. Other guys, Lakshmi Narayan, Gautam, did you guys get it?
I
Yeah.
got B, but I'm still not sure about the first statement.
Okay.
Second statement is B. Yeah.
Okay. Gautam?
I got C.
Okay. Okay, first of all, this is very complex. You got to simplify this. Okay, so you have, again, R is positive, very important. 1 over R plus S is less than 1 over R plus S. Here's what I'm going to do. I'm going to take this on this side because I can see them canceling each other out. So 1 over R plus S minus 1 over R is less than S. And sometimes you might not do that in an actual test. It's okay, you know, eventually you will get around to what I'm doing here. So R into R plus S. And this actually gave me the hint. I need to do R into R plus S because it meant that R into R plus S is not equal to 0. That means it wants me to do that. Again, as I talked about in the last week's class, that GMAT questions will keep on giving you hints what to do. So this over here is negative R and, sorry, this over here is positive R and then negative R, negative S is actually less than S. That's what the question is asking me. This and this gets canceled. So the question is asking me is negative S over R into R plus S is actually less than S. Now I cannot cut S on both sides because I do not know the sign of S. Let's look at the first statement. First statement says that R plus S is greater than 0. And I know that R is greater than 0. If R plus S is greater than 0 and R is greater than 0, that means S is greater than 0. Because if sum of two numbers is greater than 0, no, actually that does not is always the case. Let me think about that. Let me
This can be negative also.
yeah, let me think about that. If 3 plus 2 is greater than 0, yeah, it's not always the case. Yeah. So R is greater than 0 and R plus S is greater than 0. So I know that this number over here, it's actually positive. So let's try to see that. So negative S is less than S, and I have R into R plus S. And what else do I have? I have R being greater than 0, and I do not know anything about S. So now I'm thinking about plugging in here. Okay, so what I can do is, in one case, I can make S as positive, and in one case, I can make S as negative. So there are two things that can happen, right? Because from here, something that I know is that R is positive, but S could be positive or S could be negative. So S could be greater than 0 and S could be less than 0. And this is where I'm going to use numbers now. So I can use just straight algebra. That is completely up to you. So basically, you have this. You have S as positive and S as negative. So let's give S as 2, and in another case, let's give S as negative 2. And R is always a positive number. So let's give R as 2 and 2, and let's see what happens. So then I have, so then I have this particular expression here. So this expression is S less than S over R. So what is R plus S? I have to actually make it 3 because R plus S has to be positive. It's not equal to 0. So negative S over R into R plus S. So what is R plus S? R plus S is 5. 3 minus 2 is 1. And then what is negative S over R into R plus S? So that is equal to negative 2 over R. This is not working. So this is negative 2 over R, which is 3, into R plus S, which is 5, which is a negative number. This over here is negative S, which is equal to negative of negative 2, which is 2 over R, which is 3. into r plus s, which is 1. So this is positive here. So I'm getting something interesting. This over here is 2. This over here is -2. Okay, now let's actually try to see. Let's try to see what is happening here. What equality do I have? This over here is greater like this. This over here is greater like this. So I have a less than sign, I have a greater than sign. That means I have a yes and I have a no. That means this statement is insufficient. Okay, I'm gonna ask you this question now. Did you guys understand what happened here?
Yep.
Lakshmi Narayan, Priyanka, did you understand?
Yeah.
Okay, so
Yes.
okay, so the key here was, again, this is a mix of algebra and mix of plugging in. Of course, you could have kept on doing algebra there, but you have to try to identify the point. Where would you start using numbers? You have to mix both approaches together. That's what happens in data sufficiency. You have to mix both the approaches together. And here, what I did was I figured out there are two possibilities. S could be positive and S could be negative. And these are the two numbers that made all the difference, right? Let's move on to statement 2. So in statement 2, it says S is positive. So R is positive and S is positive. That means R plus S is also positive. And when everything is positive, I like to use algebra. That's just my opinion. You know, it's completely up to you. So I'm going to just do this. If S is positive, both gets canceled out. So basically the question is asking me, is -1 less than, greater than, less than R into R plus S? Well, yes, because this is a negative number and this is a positive number. So that means this is sufficient. So answer is option B.
Yeah.
Okay, Lakshmi, Narayan, Priyanka, did you get it?
Yeah.
Yes.
Yeah. Okay.
My
So,
method was slightly different than this, but this is a better method, of course. That was like not that great. So
okay.
I'll follow this method.
Yeah, and again, one thing is that it depends on the question, depends on the context. It depends on so many things, and this is something that you have to build through practice. Build through practice is that if your scratch paper is organized, you can always make a change in your approach. You can always say, oh, let me try this or let me try that. Things get complex when your scratch paper is messy. When your scratch paper is messy, you cannot go back and change things. So having a organized scratch paper is very, very important. You can see the way I plug in also. I plug in using columns. I create columns. And of course, my touchpad is not working great today, but my scratch paper would be impeccable if I were to write it clearly. So yeah, key is scratch paper. Anyhow,
What are the tips to organize the scratch paper? Because I have the idea too, but it never ends up being like as coherent as yours. So I'm just wondering like how to make that a habit apart from just trying to.
So basically the key is practice, but it can get messy, of course. When you are not able to solve a question, things do get messy, but I try to keep the rough work on the other side. So even in my actual GMAT, I kept separate sheets for rough things that I'm not supposed to come back to. So if I want to calculate this, I will calculate this on another paper and write the number here. But again, there is a balance that, again, it's very tacit knowledge. There is a balance that you have to have. You should not spend too much time organizing your scratch paper as well. But I think it comes with practice. Okay. Like plugging in columns, making boundaries between statement 1 and statement 2, writing things down, and then writing steps like that. So that's it.
Okay.
And one thing that you have to understand is that your scratch paper is just for you to understand. So you can have your own coding. I have my own coding. I'm using this for pedagogical purposes, which is why I'm making it extra clear. But usually I have my own coding. And if you look at my scratch paper, you wouldn't understand what I wrote here, but I would understand. So you can have your own coding as well. Okay?
Okay, thanks.
And that actually the question brings me, use organizing tools. Like if you take a management class, they will teach you a lot of tools. to organize yourself, and like a lot of matrices, a lot of tables and stuff like that. And that's actually completely applicable in GMAT as well. You should use organizing tools to actually help yourself out. And one of the tools that I have is the yes/no grid. So the yes/no grid, you might be seeing that I'm actually solving it in a particular way. So when you have, let's say, a particular statement, this is statement 1, and then you have a particular fact, right? So you can actually draw a, let me put it, hold on. So what you can do is you can actually draw a yes/no grid where it'll actually help you solve yes/no problems. So what you do there is you first have your variables. Let's say you have a variable X, you have a variable Y, and then you plug in the values for X and Y in columns. And then you have whether my X and Y values are satisfying the fact or not. When I say whether they're satisfying the fact or not, you would say whether it is satisfying statement 1, whether it is satisfying the fact given in the universal statement. So you could say, oh yes, it is satisfying the fact. It always have to satisfy the fact. And then you have your condition here. In your condition, you say whether it gave me a yes or whether it gave me a no. And the more values you want to plug in, you keep on plugging in here. And don't plug in more than 4 values or more than 5 values. You getting what I'm saying here?
Yeah.
The yes/no grid. That is how you should plug in your scratch paper. Gautam, Lakshmi Narayan, did you understand what I said here?
Yep, absolutely.
Yeah, that's it. So if I get a yes or no, then it's not sufficient.
Yes. And you should in your scratch paper you should plug in like this. Okay.
Yep. Thank you.
Okay. Why don't you solve this problem and take your time, try drawing the grid. Did you guys get the answer?
Yep. I got E.
Okay. Priyanka, Lakshmi, Narayan, did you guys get the answer?
I think it's E.
Okay. Priyanka, did you get it? Okay.
E.
E, yeah. So everyone got E. Actually, E is the answer. So yeah. So again, so first statement says M is. Let me do that. First statement says M is greater than 3Z. Second statement says M is less than 4Z. And you know, you could plug in numbers and you can get the answer. That's easy. But what I want to, and I hope everyone used the grid. Everyone was able to use the grid when you plugged in here. Were you able to do that?
Yes, I was able to.
Yeah. So again, there is no way that you can actually solve this in your head using algebra. You have to have numbers in this particular question. And one thing that I want to tell you is, it's very interesting, is what happens when you have to combine inequalities. Now, here it was pretty easy. When you combined the inequalities, you had M. Why is this happening? You had M greater than 3Z. You had M less than 4Z. So you could easily say that M is greater than 3Z but less than 4Z. So when you combine both of them, you actually did that. But one thing that you can do is, if you have A greater than B and C greater than D, if the signs on the inequalities are same, so what you can do is you can actually add the inequalities. You can say A plus C is actually greater than B plus D. Right? So this is something that will be very helpful to you. Whenever you have A greater than B and C greater than D, if the signs are same on both the inequalities, then you can add both the inequalities. And if you say A is greater than B and C is less than D, if the signs are opposite, what you can do is you can subtract both the inequalities, keeping the sign of the top one. Does that make sense, guys?
Try with some examples.
Yeah, but yeah, I mean, so if basically this is nothing but C less than D, you can call D greater than C. You're essentially doing the same thing. You're adding both the inequalities. So when the signs are same, you can add both the inequalities, and it will be very helpful when you're combining statements. Okay. Okay, so let's try to do this. This is a difficult problem. Okay, before we actually do this question, I actually want to tell you one thing. Guys, don't do this. I'll actually tell you one thing. When you see a question, when you see an inequalities question, the first dichotomy that you should create is, this question just about signs, or is this question about numbers? Like, if I ask you this question, is xy greater than 0? When I ask you, is x into y greater than 0? Very likely the question is about signs. I am checking the signs of values rather than the actual values. And if I say, is x plus y greater than 0? I'm more likely to check about numbers. But again, it's not 100% science. So the first thing that you think about is the question only about signs? If the question is only about signs, then in your scratch paper, if you're plugging in values for two variables, you can try positive, positive, negative, negative, positive, negative, positive, negative. Try these values, and then the answer will reveal itself if the question is only about signs. You guys understanding what I'm saying here?
Yes.
Gautam, Priyanka?
Yes, absolutely.
Yes.
So if it's only about signs, start with these four values straight away. Like, you can say if x is positive, y is x is negative, positive, negative, positive, negative. You can give it a number if you like. I usually give it 2, right? Okay, let's try to solve this question. Okay, Take your time. Okay, did you guys get the answer?
Yes, I think it's D.
Okay.
Delhi.
Priyanka and
D.
D, okay.
I don't know. I got B.
Okay. So
B.
when you see this question, you know that it's all about science. In which quadrant does it lie? So the numbers have nothing to do with it. So when you see this question, what you do is, again, the question is asking you the sign of x and y. So first statement, you write x and y, and you say plus, plus, minus, minus, plus, minus, plus, minus. Give it a number if you like. Let's just give 2, 2, 2, 2, and 2, 2, 2, 2. Okay, so let's actually see whether the fact is satisfied. Let's check the fact. So absolute of xy, which is 4, plus x into absolute of y, which is 4. This is just going to be 4 and 4, right? So this is going to be satisfied, right? So the fact is satisfied here. Let's check here. Absolute of x and y is 4 for everyone, so I'm just going to write it like this. Then you have x into absolute of y, which is 4. You have x into absolute of y, which is negative 4. Then you have x into absolute of y, which is negative 4. Then absolute of x into y, absolute of x into y, which is negative 4, which is 4, and which is negative 4. Then you have x into y, negative 4, negative 4, 4. So this is 0 here. This is gone. This is 0 here, right? So this is gone. And this is negative here. So this is gone as well. So only positive 2 and positive 2 works. So that means this is sufficient. Let's try move on to the second statement. Again, what you can do is you can just choose the same numbers here. So x and y you have, and you have plus 2, minus 2, minus 2. Then you have plus 2, minus 2, plus 2, and minus 2. Again, you are going to write what is negative of x, what is negative of y, and what is absolute of y. Don't do it in your head, just write it down. So what is negative of x? That is negative 2, positive 2, and positive 2. Negative of y, that is negative 2, positive 2, negative 2, positive of 2. And this is just 2, 2, 2, 2. And check where the fact is satisfied. So this is supposed to be less than this, and this is supposed to be less than this. It works here. Actually, it does not work. Actually, I'm not choosing the right numbers for the second statement because absolute of x has to be. So I can change the number here. So let me make this as 3, okay? Because here value matters a little bit. So this is 3. Okay, so where does it work? Okay, it works here. Oh, actually make it 1. Sorry about that. This is getting messy. Okay. Okay, so it works here. Does it work here? So negative of y is greater than negative of x. It works here as well. It works for 2. So that means if it works for 2 and you have 2 different signs for x and y, so this is gone, that means A is the answer. Do you guys understand what happened here? So basically for the second statement, what happens is that x as positive 2 and y as positive 1, x as positive 2 and y as negative 1 works. Because if you look at negative x and if you look at negative y and you look at absolute of y, this over here is negative 2, this over here is negative 1, this over here is 1, this over here is negative. Oh, actually, it does not work. I'm sorry about that.
It does not.
It does not. Yeah,
because minus y and modulation.
Yeah, this mess.
Absolutely.
Yeah, sorry about that. This mess just confused me. So you have negative 2, and then you have negative of negative 1, which is 1, and then you have 1. Actually, this does not work here. Okay, let's try the next one, which is negative 2, and then you have negative positive. Then let's try positive 1, and then this would be negative 2, and then we will try negative 1. So negative 2 and negative 1. So what is this? This is positive 2. This is positive 2. This over here is negative 1. This over here is 1. And this over here is absolute. So this is just 1 and 1. And of course, this is not going to work out here. This is not going to work out here. This is not going to work out here. So the only thing that is going to work out is here. That is both are positive. So they are sufficient. That means D is the answer. Okay. right? And again, this is in this approach, you don't even have to use a lot of your logical part of the brain. It's just computational part of the brain, which is more reliable. So I hope you got the gist why I use this question, and that's the way you should solve it. Okay. Priyanka, Lakshmi Narayan, did you guys understand?
Yeah, I got it. Yep.
Priyanka, did you get it?
Yeah.
Okay. 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 Did I have the rules? Okay. Let's. Okay. And again, strategy number 6, what I wanted to tell you was plug in systematically. And I think I have shown you that that you should always try to plug in systematically. If you see the question is just about signs, plug in different versions of signs. If you see the question is about values, try 0, try 1, try negative numbers, try fractions, and all that. And then there are a few rules that I have talked about this about inequalities. Those rules are like whenever you multiply or divide by a negative, you must flip the sign in an inequality. Like if you have a greater than b, if I divide by a -1, then negative a is actually less than negative b, right? So that's something that we have been using. You can't multiply or divide unless the sign is known. So if you don't know the sign of a variable, if you know a is greater than b, you do not know what is the relationship between ax and bx, right? So you have to know the sign of x, and you also have to know whether x is 0 or not, right? So you need to have a lot of information about x, and many questions would be created on this basis. You can add the inequalities. If I said if a is greater than b, c is greater than d, you can actually add them up, right? You can subtract the inequalities as well, right? So if a is greater than b, c is less than d, you can subtract them by keeping the sign of the top one. Okay, and when you see x into y greater than 0, that means either both of them are positive or both of them are negative. You see x into y less than 0, that means either of them is negative. If you see x over y is less than 0, that means either both of them are either one is positive, other is negative, one is negative and other is positive. If you see x over y greater than 0, that means both of them are positive and both of them are negative. If you see x over y greater than 1, that means either x and y are positive, and in that case x is actually greater than y, or both of them are negative. In that case, x is less than y. Right? So if x over y is greater than 1, then these are the two things that come out of it. Okay? All right. Why don't you guys do this question? Before that, did you guys have any question on what I just spent through? Do you guys have any question on that? Just let me know. If you have no questions, say no.
No.
Okay. Okay. Okay, did you get the answer, guys?
Yeah.
What was the answer?
I think it's B.
As a ball? Okay. Other guys?
I'm not able to solve it, as in I was busy somewhere else. So I just couldn't. I just solved the first equation, so it's insufficient. Obviously, it's going to be among BCE. So I was about to solve the second one. So we can
Okay.
move on.
Okay. Let me solve it with you guys. Okay. So the question is asking, is x, y greater than 0? I mean, it's mostly about signs. Let's talk about this. X is greater than y minus 2. Now, when you plug in for two variables and there is some kind of relationship between two variables, plug in for one and then deduce the other. So what I'm going to do is I'm going to plug in for y. Let's say that y is 4. If y is 4, then what about x? That means x has to be greater than 2. If y is 4, x has to be greater than 2. Let's take x to be 3. It is satisfying my fact, but what about my condition? It gives me a yes. Let's take y as negative 4. If y is negative 4, then x has to be greater than negative 6. X greater than negative 6, x could be minus 3. Does it satisfy the fact? Yes. Does it satisfy the condition? No. Insufficient. B, C, or E. Let's see the second one. In here, x is less than 2y minus 6. Now, x is less than 2y minus 6. That means, again, I can just start with y. If y is 4, what is x? X is less than 2. If x is less than 2, then x could be 1 or x could be negative 1, right? If x is less than 2. That means what about xy? Xy can be positive here, so it's a yes. It can be negative here, so it's a no. So it is insufficient. You guys understood what I did here?
Yes.
Priyanka, did you understand?
Yeah.
Yeah, so see the way I am choosing numbers. I chose a number for y and I had a relationship between x and y. Using that relationship, I came with different values of x, right? And that's something you should do. Now let's combine both the statements. Now, when you combine both the statements, you tend to use more algebra because you have more information about x and y. So you have x minus y greater than negative 2, and you have x minus 2y less than negative 6. When that is the case, you can subtract both the inequalities when the signs are opposite. So this is negative, this is positive, and this is positive. X gets cancelled out. Then you have 2y minus y, which is y. And then you keep the sign of the top one is greater than 2. Y is greater than 2. And pick up any of these inequalities. Let me pick up the first one. X minus y is greater than minus 2. And y is greater than 2. So from here, x is greater than y minus 2, and y is greater than 2. If y is greater than 2, and do I have it correctly? Oh, y is greater than 4, I'm sorry. It's 4. because 6 minus 2 is 4. So x is greater than y minus 2 and y is greater than 4. Again, what you can do is you can add both the equalities. You can have x plus y greater than y plus 2, and y would cancel out. That means x is greater than 2. X is greater than 2, y is greater than 4. That means their product has to be greater than 0, which means C is the answer. So did you guys understand this expression here? Guys, let me know. Do you want me to re-explain the combining part, or is it fine? Guys?
Yeah, I need to look at it once again, just understanding.
Okay.
This whole thing I understood, but then when I need to apply this to other solutions.
Okay. Okay. At least you understood the question, right? What I did here in this question.
Yes, this question I understood.
Yeah. Priyanka and Gautam, did you guys understand?
Yeah.
Okay.
Yeah.
Okay, cool. Okay, so yeah, so this was adding and subtracting inequalities. Now, yeah, so what I will do now is kind of summarize. We're almost out of time. No, we have 20 minutes. Okay, let's talk about a little bit about modulus as well. Modulus it can get really tricky, and there is some conceptual logic that you need to understand. First thing is, if I say absolute of x is equal to a, there are two things that come out of it. Either x is a or x is negative a. And if I say absolute of x is greater than a, then again, x is greater than a, but less than negative a. Same goes for if absolute of x is less than a. X is less than a, but greater than negative a. Basically, what you do is you keep the sign here, same, right? And again, understand these are possible values. These are not actual values. You don't need to stop here. You're supposed to plug in back into this and check whether the values work or not. Okay, so if I say absolute of x minus x square minus 3 is equal to 6, then you get x square minus 3 is either equal to 6 or x square minus 3 is equal to negative 6. So you get x square is equal to 9 or x square is equal to negative 6 plus 3, which is negative 3. You know this cannot work because x square cannot be a negative number. So from this, the only answer is this. So this has only one answer. This does not have two answers. Did you guys understand the trick here?
Yep.
Okay. So three things that you have to remember for modulus is this part, and this part. Okay, let's see a question. I will pick up a good question. I want a good question. Okay, let's see this one, guys. Okay, did you guys get the answer?
I got an E, elephant.
Okay.
E.
Okay. Lakshmi Narayan, did you get it? Get the answer?
No, I'm still following.
Okay. Should I explain? Or do you need more time?
Yeah, you can, because I got stuck in a loop here.
Okay. Okay. So the question is asking what is X? First statement only tells you that X is between 2 and -2. So that does not tell you what is X. Second statement gives you two things. That X is equal to 3x minus 2 and negative of X is equal to 3x minus 2. Here it says that 2x is equal to 2, which means X is equal to 1. Or it says 2 is equal to 4x, that means X is equal to half. These are the possible values. These are not the real values. You're supposed to put them back in here. Is absolute of 1 is equal to 3 into 1 minus 2? Yeah. Is absolute of half equal to 3 into half minus 2? No, because this is negative half. Absolute of half cannot be equal to negative of half. So this is not a possible value. That means X has to be 1. That means B is the answer. Did you guys understand what happened here?
Yeah. I always forget to put it back inside the equation.
Yeah, and that's normal. I always used to do that as well. But you know, with GMAT, if you see the question is too easy, you should always stop and try to see there is something happening here. Okay, Gautam, did you understand?
Yep.
Okay, great. Okay, so yeah, let me just I will just post all these questions on your course as well. But I want to take a moment.
Will the answers be available for those?
Come again?
You know the questions in your presentation. Will the answers be available?
I would I will just post the slides. For the slides, the answers are not available, but then I will post extra questions like. There would be around 200 to 300 data sufficiency problems, which will have answers and possibly solutions as well.
Okay, thank you.
Yeah. So let me just take a step back to understand what we did today, right? So to summarize, we first started with that there is a process to solve data sufficiency problem, which is the ADBCE approach. That is that this is the consistent process with which you're supposed to solve the problems. Then we moved on to how to set up your scratch paper work. So you should have your scratch paper nice and clean, boundaries between different statements, very important. And then we moved on to different commandments that you should that are important for data sufficiency. Those commandments included simplify statements. You can solve backwards, or you can solve you can solve using the universal statement, or you should always try to negate what the question is asking you. So those were the commandments that we did. After that, what we did was we did some strategies, and in those strategies we talked about even I forgot. Yeah, so go all the way, convert from English to math, talk about invisible constraints, inequality versus equality, there's a difference there, and use organizing tools. So we talked about the yes-no tool, all those tools. And then we moved on to some concepts about inequalities and some concepts about modulus, right? So hold on. Yeah, so that was the gist of it. So here's what I want you to do. Again, you will have this video recorded on your course. I will also post questions on your course curriculum. Try to solve at least at least 20 questions a day. And once you solve those 20 questions, from every question, try to understand what is the takeaway from each question. What did you understand? Were you able to solve the question efficiently or not? And typically what I ask students is to kind of categorize the question in NMGFH. So not NMGH, sorry. So you nailed the question.Id you just solve it correctly, completely in the most efficient way? Did you miss the answer? Was there a just a small issue with your with your strategy, and you just missed it? Or did you guess the answer? Did you just made a guess, or do you actually need some help to actually solve the answer? You have no idea. Or F also, do you need a faster way of solving the answer? So try to categorize your question when you solve it using these categories, and then let me know what you're feeling. I'll be available throughout the week on the chat and on the forum as well, and you can always ask me. So before I hit the end button, is there any question that you have for me?
I think I'm good. But thank you. Thanks a lot for clearing out most of the doubts, for at least my doubts. So really helpful session. Thank you.
Thank you. No problem. Thank you. Lakshmi Narayan, Priyanka, do you have any doubt or question?
No, not at the moment, but I'm sure I'll have it later.
Sure. Yeah. Use me. I mean, utilize me and ask me questions throughout the week. Okay.
Sure. Thank you so much.
Cool.
Thank
All
you.
right. So I would end the session now and have a good week.
Thanks a lot.
Thank
Same
you.
to you. Bye-bye. Thank you. Thank you.
Bye-bye.